Hello everyone, thanks for joining our webinar on introduction to creating and optimizing real-time 3D graphics in Qt. During the session, if you have any questions, please submit them via the Q&A button at the top of the interface. Those questions will be answered at the very end. This webinar will also be recorded and you will receive a copy of it delivered to your email account. I hope you enjoy the webinar. I'll now hand you over to our expert, Teemu Tamminen. Over to you, Teemu.
Okay, thanks. So welcome to all, also from my point, and let's get this started. So this is a quick overview of the webinar. So we are gonna shortly go through what is real-time rendering and why it's being used. Then I have a couple of examples or demo projects with Qt 3D Studio to show some general optimization tips for your real-time 3D applications, and then as said, the Q&A at the end. So who am I? I'm Teemu Tamminen, working as a senior technical artist at the Qt company. I've been working couple of years now, and working as a part of the Qt 3D Studio development team, mainly as an end user for the tool. So working as an artist inside the development tool that's creating a tool for artists. So giving lots of feedback and feature requests and testing the tool. And now to the real thing. So what is real-time rendering? And I think the best way here is to skip all the rendering pipeline things and keep things simple. So let's assume that we want to create a project that has a three-dimensional cube, and that cube must have three different positions to be in the screen: left, right, and top of the screen. And we also want to have animations for the cube to move from position to another. And three buttons to control three different states of the scene. So there is two ways to produce this kind of thing. And the first one that comes to my mind is the real-time rendering way. So creating a 3D scene with cube as a mesh file and animations being calculated and images being generated in real time. And the other way would be to use pre-rendered image sequences, which is basically a movie. So pre-rendering video files for each animation and controlling the playback of these videos through users' input. And I will now show you an example in Qt 3D Studio where we have these two layers here, which the first one has a camera, light, and these three rectangles representing the three buttons we want to have, which each one has an action. So on pressure down, go to the state, or in Qt 3D Studio, we have slides. So we have another layer which has the cube, and then three different states for the cube. And now if we run this presentation, we have controls to move this cube from position to another. And then let's get back to the PowerPoint. So what if we would create this same thing as talked before with another way? Instead of real time, we would need to render three movie files for the cube mesh to move between three different states. So that would be, I tested it before, and it would be roughly 15 megabytes in total size for those animations. And in real time, the same thing with created in Qt3D Studio with imported cube mesh file as an FBX. It's total size of 16 kilobytes in size, so it's 0.1 size of the pre-rendered version. So the results are that, as seen, this example shows that pre-rendering uses much more resources. But however, if we include 100 textures to this same scene in both of these versions of the thing, the pre-rendered video file, the size of this thing would stay the same. But in real-time rendered application, the application would increase in size and might not be even able to render 60 frames per second, since all of those resources need to be loaded into memory. So then, why to use real-time rendering? Is the reason that real-time rendering brings interactivity to your scene. So let's get back to Qt3D Studio. So we are using the Qt3D Studio's dynamic keyframes feature, which allows us to dynamically change between all of these states, even if we are in transition between, for example, from left to right. We can in the middle we can interrupt the transition and move to top and interpolate from the current position. So let's run the application and show what is the reason why we have real-time graphics. So let's click the button to move to the right side of the screen, and then interrupt the animation by clicking the center button and moving to the top. So to achieve this same effect with pre-rendered content would make no sense, because we would need to have video files for each of these possible positions for this cube, and I don't even want to think a way that, or a work that that would result to do such a thing. So the interactivity is the reason why we use real-time graphics. So now because it's clear why we use real-time graphics, now let's jump into looking some projects. So let's open another project in Qt3D Studio. We have this instrument cluster project, and now let's talk a little bit about the performance of this. So let's run the application or the presentation, and first thing is that we need to look the overview of the profiler. So how this computer is managing in running this application or presentation. So we can toggle the profiling here and see the frame rate. So it tells in milliseconds how many milliseconds it takes to render a frame. So it's roughly about 25 milliseconds right now. So it's not reaching the magical points of 16 milliseconds, which would mean that it can render 60 frames per second. And I'm not sure, can you there see the flickering of the needle while it's moving, but for me it's clear, and we need to make this run 16 frames per second instead of, it's like roughly 45 right now. And through scene info, we can also open the Qt3D object list and see how much resources we are actually using here. So as I'm looking at this scene right now, it looks like there's like 2 gauges with needles and a car model. So that would be something like 10 different meshes, but mesh files. But for some reason, this project has 61 mesh files. It has 23 2D textures, which some of are over 4,000 by 4,000 pixels in size, and actually there's a lot of these things. And then frame buffer objects, we have 25, so everything that needs to be rendered and composed later will be generated as a frame buffer object to be used later to compose into the final output. And then we have 16 shader programs running. So let's have a look in this Qt3D Studio how we can actually start cleaning this up so that it would run. So the first thing is cleaning up all invisible items. So if we have something in our presentation, like for example this test layer here, so we have been testing something before, how would things look like, but we have just disabled it. Of course, it will be added to the final presentation because we can control the visibility through input. So this layer and this blur post-processing effect here, this rectangle, camera light, this group under here, there's lots of groups under this, and there's material files that will also have shaders compiled for them. We don't need this because it was disabled, so let's delete this. That was the first thing. Do we have something else here? Of course, there's a hidden light here that wouldn't even make a difference if we enable it, so just delete that also. So that's the first step. So deleting everything that's hidden or are maybe used for testing things up. Then we have next thing is the background layer. So we have this background layer here, which let's disable everything else so we can actually see what's in this layer. So we have a rectangle here. Let's disable these things also. So we have a rectangle which has this nice color here, and then we have a color master script which we can control the color amount and saturation of the color, and then we have the vignette effect which will create this nice vignette around the edges of this screen. So all of these things can be made in many ways that would perform better. So how I would do this is just to replace this thing with a texture, and we can just import a new texture here. I have pre-made the texture, so I will add it to the layer. We have it there now. I will disable these effects and delete the rectangle and these effects and scale this texture to fill the screen. And because we don't need the light, we can delete the light also. And why this turned black is because we have the material is using pixel lightning. So just set this to none, and now we are generating a better performing shader that doesn't calculate any kind of lightning. So now we have that layer there, and let's enable all of the other layers and just check have we made any different from the 25 milliseconds. Yeah, that's 24, 23. right now. So that was a difference. So let's have a look at the second point. We have a text layer there. This text layer. So what kind of, I have the layer size thing for this. So we have this, let's look at under the Studio's presentation settings that we have 1920 by 720 sized presentation. And we have a layer that is being generated as an FBO texture of that size, even though we have only this small part here that is being rendered. So it's huge transparent texture with just a small little text element here. So let's resize this layer. So let's create a smaller width for the layer, then height for the layer, then position it correctly. So it's somewhere in the center and somewhere at the bottom. And then we don't need this shadow text, and we can just move this text to center now. And now we have a lot smaller texture being generated for this layer, because all of these layers will be will create an FBO frame buffer object, which will be then later to be composed into this final thing. So generating a lot smaller texture will use a lot less resources. And the light is also something that we don't need here. So let's have a look how much improvement we have made. So let's look at the frame rate again. Let's wait some time. Maybe this will give us something. So it's still there, 23, 24. So not much improvement yet. So let's take a look at something else. So 3D car layer is using a sub-presentation. So what a sub-presentation is that this whole thing here is a presentation, and then we can have different presentations inside a presentation. So let's open the car presentation here. So this is also being rendered on a layer. It has this generic coupe car model, which has lots of mesh files, and all of these have materials under these, and this also has a huge texture. Instead of, it could have been something like 500 by 500 pixels in size, so it would fit to rotate in the screen. I will not fix that in this project. I will continue another project shortly, but I will still go back to the main presentation to look something else. So would it make sense to combine all these things, combining these layers, reduce the amount of frame buffer objects, or combining these meshes or something like that? So let's have a look at that. So do we really need this text layer, or is it possible to just remove this frame buffer object totally and just move the text into the same layer with the gauges? No, it's there. We can remove the text layer. Do we need these lights? Yes, they're affecting the scene. Then the background. Can we move the background rectangle to the same? Let's try moving it there. And then we need to move it behind. Yes, it's now in the same layer. We can remove the background layer. And then we have the 3D car layer. So this is using a sub-presentation. So it's rendering another presentation into this layer. And it's now behind this layer, and it's not visible because we added the background there. So for it to be visible, we need to move it in front. But we don't, even in this case, we don't need this layer either, because we can totally add the same model here, this coupe, to this same layer. And then we can get rid of this 3D car layer. So now we have one layer. And let's I will quickly create a component for this, so it will have the same kind of rotation animation it had before, so we don't lose any information. So let's create a rotation animation for this. Quickly create a keyframe there, and then another at the end. 0 to 260. Yeah, the rotation is not exactly the same, but and then convert these keyframes into linear interpolation, so it's looking exactly the same. And now make this component to loop the animation. And now let's run the presentation. So, like you see here, this actually shows weird numbers. I didn't expect this to happen. So we will look at this at the another presentation shortly, because I have this running much faster than this. So that was unexpected. But we can still look something. So this is using multi-sample anti-aliasing. So if we change this to 4x, so it's only 4 times. And then let's have a look again. Okay, so the car itself actually made this perform worse. So let's jump into another presentation where I show you how this thing can be created in the most optimal way. And we will start it from, I will show from Blender, which is a 3D modeling application. Let's not go there yet. That how is this in the version that you just saw? How is this built up? So we have these 3D meshes for both of these gauges, and they have these needle meshes. All of these are separated parts, and this whole thing has 66,000 vertices. So it's a lot, and this is huge in size and uses lots and lots of resources. So the most optimal way to creating something like this is to combine things together. So here I have another version of the same thing, where I have combined this needle part and the background as same thing. And I have also baked the lighting and color information into one texture, which is looking like this. So all the lightning information is in the same texture and the needle. So it's just one part, and then I can just simply rotate this mesh inside Qt3D Studio to achieve the effect that we had before, that we had actually a light component under the needle here. So we can find the speed gauge here, and then somewhere under here is the needle, and under this needle there's light, actually real-time light that's affecting the lightening all the pixels in the scene. So baking that information into texture will allow us to remove those lights from the scene, and also in the other example of the instrument cluster we had two of these gauge meshes, but of course we can combine these numbers and these small tick marks into one mesh and these into another, and then have only one of these meshes, because we can needle meshes, because we can use this same as a shared resource between both of these gauges and have much less smaller file size for the FBX file. And of course, compared to 66,000 vertices, this 3,781 is much less. And now let's jump into looking how this presentation, how this presentation looks at the end. Let's save that. So this is the presentation that has basically everything else, everything same visuals that the first presentation had, but the difference is that this is actually running 16 rendering frames in 16 milliseconds, which is exactly what we wanted it to do. So it's running 60 frames per second, and from the scene info, from the object list, we can see that currently, and we can even fit this thing into the screen without scrolling it. So we have only 6 mesh files and 6 textures. So these were something like, I don't remember, something like 50 and 22. And the render target, so the frame buffer objects, is only one frame buffer object. So this is something that would maybe run even on an embedded device, which usually is the case for these kind of instrument cluster presentations. So I will quickly show you how this thing is built. So there is the low poly coupe as a component, and this is a bit different from the one that we had in the previous one, because this is just one mesh, and all the information on those lights and details and everything is baked into a single texture file. So I will quickly show that texture file. If I can find it, it's under the maps. So here you can see a texture that has all the information for the car. So much less resources. So let's have a look at the file size of these. This is the project that we had before. It's 100 megabytes in size, and the result is under 2 megabytes. And the end result is the same. So that's the kind of the basics of how to optimize or design optimized presentation to just sharing resources and understanding that don't have objects in the scene that are not being rendered or not have a huge visual impact to the scene, and that example on how the background layer was created before it was generated with scripts, effects, and textures inside a layer, because it also could have been created a way that we have it now, that we have a pre-generated texture for the background, and that's saving lots of resources. So that's pretty much about what I have to tell about this, and I would like to answer some questions if you have. It took about 30 minutes. So
yeah, please submit your questions via the Q&A button at the top of the interface. We'll give you a little bit of time to submit them.
yeah, and if nothing comes to your mind, is one thing that I remember that was frequently asked from many of our customers is that because they have lots of text elements in the Qt 3D Studio scene, and they want to have shadow effects for those text elements, and the current approach to achieve this is only to have custom shader effects for the whole layer, or to duplicate all of the text elements, which is really not the way to do it, to duplicate all the items in the scene. And even if you have animation for all of these text elements appearing and scaling, you would need to do those animations and calculations to all of those duplicate items. But we have something for that coming in I think it's coming in 2.2 release of Qt 3D Studio. We will have shadow properties for textures, so you can enable shadows and move those shadows under a text element.
Thanks, Teemu. It doesn't look like we have any questions today, but if you do come up with any questions after the session, please send them to info@qt.io, and we can answer them for you then. Like I mentioned in the beginning, you will also receive a copy of this webinar via an email. But thank you so much for joining. Thank you, Teemu, and
yes, thank you.
I wish everyone a great day. Until next time, goodbye.